Hello, welcome to the program. My name is Michael Finney. Today, I am joined by Hans Schantz. Would you like to say hello, sir?
Oh, well, thank you so much for having me on.
Yeah, I appreciate you taking the time. Let's talk a little bit about your background, what you do professionally, and how that gets us to where you're at today with the projects you're working on.
Sure. I started off studying engineering and then made a sideways step into physics. I got my PhD in physics. I used that to go into working in the area of ultrawideband antennas. My interest is in electromagnetism and how it works, and energy flow and time domain analysis of electromagnetism. And ultra-wideband antenna design was an area where all of those technical interests really converged in a very practical way. After my first professional job doing ultra-wideband antenna design, I got together with some friends and founded a company called Q-Track to commercialize near-field electromagnetic ranging technology. That's a short-range, low-frequency, long-wavelength technology that allowed localization of transmit tags to within a couple feet or so in cluttered indoor non-line-of-sight environments. That company was acquired a couple of years ago. I kind of came along with it. Now, currently, I'm working in the defense arena for a defense contractor. So my background has been as a scientist, an engineer, and an inventor. And about 10 years ago, I started writing fiction. My first novel was The Hidden Truth. I've written two more in those series. It's an alternate history, kind of conspiracy techno thriller. I've also written a book, The Whys of Heart, which is a courtroom drama about biological science versus transgenderism that brings the Scopes monkey trial up to date for the 21st century. On the nonfiction side, I wrote a textbook, The Art and Science of Ultra-Wideband Antennas. And my current project is a book, Fields and Energy, How Electromagnetism and Quantum Mechanics Work and Where Physics Went Wrong. And I'm serializing that on Substack. I also have an interest in the indie writing community, promoting not only my own books, but other books from Based authors, and I launched the Based book sale a few years ago, where indie authors come together to put their books on sale for the same week, about 4 times a year, and we all mutually promote it and see how many Based books we can get into the hands of Based readers. So that pretty much encompasses the scope of the things I've got going on.
Yeah, very cool. I want to drill down into a couple of things that you mentioned. I want to hear about the overlap in regards to ultra wideband and the electromagnetics and ether physics. What came first? What has kind of drawn your attention into the esoteric aspects of that?
Sure. My doctoral research in graduate school was on electromagnetic energy flow. And the specific project that I worked on was understanding the exponential decay of a dipole. That's kind of a mathematical way of talking about the discharge of a capacitor. If you charge up a capacitor, you have equal and opposite voltage, equal and opposite charge, then you short out the two capacitor plates through a resistor and it starts to discharge. The mathematics that describes that is something called an exponential decay. And what I discovered is if you take a look at the fields around that exponentially decaying dipole or that discharging capacitor, there is a surface, kind of a bubble, whose radius is equal to the speed of light times the time constant of the decay. And on that bubble, the magnetic field goes to zero, and energy flow depends on having both an electric and magnetic field. So if one of them goes to zero, there's no energy flow. So effectively, what I discovered is this process takes place inside a bubble through which there's no flow of energy. And yet there's electromagnetic radiation taking place. What I was able to demonstrate is that the energy that is radiated is the original energy stored in the static fields outside the bubble before that decay happens. And that's a really fascinating example, because to the extent physicists think about how electromagnetism works at all, they normally think in terms of accelerating charges wiggling and popping out photons, and then those photons carry the electromagnetic energy from place to place. What my research showed is that the radiation energy doesn't come from the accelerating charges in that case. The fields propagate out and then pick up the energy that's stored in space. So it really, I didn't quite understand the significance of that at the time. I thought it was very curious. But that example that I studied so thoroughly in my doctoral research is really what led me to my thinking on electromagnetism, which is that fields guide energy, that electromagnetism is due to two different things. Now, the conventional wisdom attributes electromagnetism to one thing, a photon, which simultaneously has the properties of being a localized point particle and a non-localized wave. Of course, that leads to all kinds of problems when you try to reconcile those two mutually contradictory properties. In my thinking, electromagnetism is due to two separate phenomena: fields that propagate through the environment in a non-local fashion, behaving like waves, and energy, which does have a discrete location, which flows around from place to place in the quantum limit. It's made of particles. So that perspective of trying to understand and track energy flow got me into my first job doing the ultra-wideband antenna design. One of the neat things about ultra-wideband antennas is if you want to make an antenna broadband, you need to design an antenna that doesn't store the energy. You need to have an antenna that just lets that energy flow straight on out into space instead of being stuck to the antenna and resonating and bouncing around. So by taking my understanding of electromagnetic energy flow, I was able to figure out what kinds of shapes of antennas would work best and have minimal stored energy and maximal bandwidth. So that's what I did in my first couple of years working for a company called Time Domain, and I designed some of the first commercial ultra-wideband antennas. The FCC had just authorized operation of ultra-wideband from 3 to 10 gigahertz. So those kind of abstract and fundamental ideas on electromagnetism and how it works, I was able to put to practical use in real-world applications doing those antenna designs.
Yeah, very cool. I want to touch on the handle that you use, right? Ether czar.
Mm-hmm.
And the lineage of physics going back to the 19th century and where things were at that point in terms of this not necessarily completely defined concept of ether, and then where we get in 20th century physics. I assume you touch on a lot of this stuff in your writing. You know, I have not read too much of this material at present. You know, we're new friends, but at the same time, I've poked around on your Substack, which you mentioned, and I try to absorb as much of that as I can. But maybe for listeners, for me, you give us a little bit of the shorthand on where things were in the past and where they were perhaps funneled in the more recent past.
Oh, sure. And it's a fascinating subject because A lot of this stuff is taken for granted. It's stripped out of the educational curriculum to make room for more material. So all of the history and the process of how we figured these things out and what theories were discarded is oftentimes just ignored. And that's part of what I'm doing in my book, Fields and Energy, which I'm serializing at Etherczar, AETHERCZAR.substack.com. You can go back and take a look at, Isaac Newton is probably a good starting point if you want to talk about modern physics. He came up with his universal law of gravitation and famously said he would feign no hypothesis. He wouldn't speculate about how gravity worked. He just had a mathematical description, and it worked. And that was as far as he was willing to push it, because he didn't really know what it was or how fundamentally what process gave rise to that inverse square law that he discovered. That wasn't good enough for a lot of Newton's successors, and they started coming up with a theory of how reality works that involves everything being little point particles that interact via mathematical force laws with each other. And that culminated in work by a Jesuit scientist, Boscovich, who basically came up with that model of reality. Everything is point particles. Everything interacts with force laws. It's really very similar to the kind of picture a lot of physicists use today. Well, then early electromagnetism got described and developed with that kind of perspective in mind. So we ended up with a Coulomb's force law, which looked a lot like the Newtonian force law, the same kind of way. And elaborate mathematical laws were derived by people like Coulomb and like Ampere to describe the interactions of moving charges. You're treating them as point objects that interacted via mathematical laws. Along came a very brilliant physicist named Michael Faraday, who was not very mathematically inclined and frankly couldn't follow the math that everyone else was using. So he developed a very intuitive picture for looking at these things. He noted how if you sprinkle iron filings on a magnet, they'll form lines in the space around magnets. And he interpreted that as lines of force pervading the spaces around magnets, around charges. And then James Clerk Maxwell took that kind of intuitive picture and developed the laws of electromagnetism to mathematically describe Faraday's insight. In Maxwell's view, energy is stored throughout space and it moves from place to place. Now, that moving from place to place part was actually identified by two physicists, John Henry Poynting and Oliver Heaviside, a few years after Maxwell died. They discovered that if you have electric and magnetic fields operating at right angles to each other, they will guide the flow of energy through space. And then when Heinrich Hertz came along and he did his famous experiments transmitting and receiving electromagnetic waves, he caught energy in the act of moving from place to place. So instead of some mathematical law relating the motions of charges in one place to the motions and forces on charges in another place, Hertz described a picture of that energy moving progressively from place to place through space. So the intervening space was playing an active role in storing and moving the energy. And that was the mathematical basis for the ether theory, the idea that all space is pervaded by this material of some kind called an ether that has the ability of storing and conveying energy. Well, then people started investigating if we could detect motion with respect to the ether. And Michelson and Morley, two American physicists, built what's called an interferometer, where they bounced light around on a path that, two paths that are at right angles to each other, looking for variations in how the light travels. and they found a much smaller variation than would be anticipated if the Earth was moving through an ether, and if the light was being retarded by the amount of the Earth's known motion. Now, the interesting thing is Michelson and Morley didn't find a zero result. They found a very small result. And a lot of people, well, let me back up and go talk a little bit about Einstein and relativity. People like Lorentz and Fitzgerald used electromagnetic theory to try to explain the Michelson-Morley result. They argued that perhaps as objects move through the ether, they get smaller, or perhaps there are time dilations or variations in the rate at which time flows. So they developed kind of a bottom-up theory of how electrodynamics in an ether could give rise to those observed effects. Well, Einstein, in 1905, published a paper that took a completely opposite approach to the problem. He took a top-down approach, where he started from the assumption that the observer always sees the speed of light being the same in all reference frames. And from that assumption, and from the assumption the speed of light is constant, he deductively derived the relationships that had been identified by Lorentz and by Fitzgerald and others, and developed what came to be called the special theory of relativity. And one of the arguments that was made in that is that, well, now we don't need an ether at all. We can have waves without a material in which they are waving or oscillating. They're just mathematically defined, and we have no need to appeal to an ether to do physics. Well, then when Einstein applied that to the problem of understanding gravity and developing the general theory of relativity, he adopted a picture of space as being a place where there is a certain curvature associated with empty space. That curvature tells the objects in it how to move and is the source of what we perceive as gravitational acceleration. And that curvature is governed by the mass and energy distribution of space. A teacher I had named John Wheeler liked to say that matter tells space how to curve, and space tells matter how to move, is the essence of what general relativity had to say. So, in essence, Einstein, while dismissing the classical electromagnetic ether, was introducing a new kind of ether of curvature of space pervading all through space. That's been very controversial. A lot of people have continued investigating that issue, and one of the fascinating things is that there are persistent results that demonstrate the speed of light does seem to vary based on time of the year. A man named Dayton Miller did a very thorough and systematic repetition of the Michelson-Morley experiment, setting up an apparatus on top of Mount Wilson in California. So on top of the mountain in a very flimsy structure to try to minimize any interference with a hypothetical flow of ether. And he was seeing very consistent results that suggest that there is some kind of a systematic variation there. And that's one of the things I'll be talking about on my Substack in the coming weeks. I'm going through and studying that right now. So there's just a fascinating amount of work that has been done trying to understand those fundamental aspects of electromagnetism and how it works. The prevailing attitude in physics is kind of summarized by shut up and calculate. If we have mathematical formulas that describe what's going on, that's good enough. And speculating about mechanisms and processes and how these things really work isn't regarded as very productive. In my experience, having that kind of a physical picture really helps you understand the math and keep you out of trouble. So that's what I've been doing in my career, taking this ether picture, the notion that energy is stored in space and it moves from place to place. In my view, that motion is governed by fields that are a separate phenomenon from the energy. The fields go one way, the energy goes another way, and the fields serve to guide energy through our electromagnetic systems. So that's the fundamental approach that I take to electromagnetism.
Super interesting. Appreciate you going into all of the depth of that history. And to me, I feel like if all of that past research, experimentation, and everything is so simple and fundamental that we don't even need to be concerned with it, and just shut up and do the math, well, then it should be really easy to give kids the opportunity to play with those same ideas and to make that part of a curriculum early on, to where they get exposure to that stuff to advance their thinking so that they can catch up more readily and more rapidly to shut up and do the math. No?
Oh, right. And if having a physical picture of what's going on really makes it a lot easier to do any sort of science. Feynman once commented that if you wanted to encompass the greatest amount of information in the least amount of words, you would tell someone all matter is made of atoms. And if you have that picture of matter being made out of atoms, you can understand immediately why there are specific ratios of, say, hydrogen to oxygen that come together to give you water, and a whole host of other phenomenon. Having that simple physical picture provides the framework within which you can understand the math and understand the equations. In the context of electromagnetism, even the physicists who are telling you shut up and calculate, we use the math, we don't use models, we don't use physical pictures, implicitly, by and large, are taking Feynman diagrams. That's a technique Feynman came up with to keep track of the terms in series expansions in quantum electrodynamics. And it involves drawing lines to show the motion of charges, and then squiggles to show, this charge is emitting a photon, and then that charge is rebounding or accelerating. And when people do that, for instance, you run into a problem when you look at an accelerating charge. If you have a charge that is accelerating, and if you assume that charge is emitting a photon, you can look at the reaction force that radiation photon is exerting on the charge that is its source. And that reaction force gives you more acceleration, which should give you more radiation, and more acceleration and more radiation, and so on and so forth. You get an exponential runaway process. It's called the problem of radiation reaction. And it's inherent to that model if you assume a point charge emits a point photon. But there's a different model that I think is better. Now, you may have heard of the Zen, I guess they call them cones. They're these aphorisms or paradoxes that you're supposed to ponder in order to gain enlightenment. And one of them is to consider the sound of a single hand clapping. Of course, that doesn't make sense because clapping is a phenomenon that requires two hands. You don't get applause unless you have two hands coming together. A single hand will not give rise to applause. You've broken the system down in your reductionism to a level more fundamental than the broader context needed to understand the phenomenon. And it's really the same way with electromagnetism. Talking about the radiation of a single charge makes as much sense as talking about the applause of a single hand. A charge does not accelerate and radiate unless there are other charges there to make it accelerate and radiate. And when you do a detailed analysis of the energy flow around an accelerating charge, you discover that an accelerating charge doesn't emit energy, it absorbs energy. It's moving faster. It's a little tiny current that's getting bigger and bigger, getting magnetic energy around it. Or mechanically, it's got a kinetic energy that's increasing as it accelerates. So an accelerating charge is absorbing energy. It's not emitting energy. And if you look at where does the radiation come from then, you discover that that radiation is coming from the field that is causing the acceleration of the charge. So that reaction that people worry about that gets them in so much trouble trying to understand radiation reaction, it's a non-issue because the photon, the radiation energy, doesn't come from the accelerating charge. So that's an example of how these kind of simple intuitive pictures about how electromagnetism works can help you avoid misapplying the math or making erroneous assumptions about how reality is supposed to work.
Excellent. I think this is a great point to transition into some of your fiction work. And I would ask, how has this background in science and engineering, technology, mathematics, physics influenced your writing, your subject matter, your work in fiction as a writer, particularly the Hidden Truth series? Let's start there.
Sure. Now, of course, my first book was my ultra-wideband antenna textbook, and that was a case where I wanted to be able to define my approach to ultra-wideband antennas, and I was really disappointed that so much of the wisdom and knowledge on this subject was largely just not available. It was buried in papers. It wasn't in textbooks, and I wanted to capture that in my book. When I was updating the second edition of the textbook, that's when I really made my breakthrough understanding how fields and energy work together. That was like in around 2014 or so. And after I had finished that textbook, I was really tired of doing technical writing and having to do equations and references and figures and so forth. But I was enjoying the writing part. I decided to write some fiction instead. And in particular, it had puzzled me that all of the fundamental concepts I was coming up with for how electromagnetism worked, it really puzzled me that those ideas had not been discovered over 100 years ago by people like Hertz and Heaviside, who were exploring those same concepts in much the same way I was looking at them. So I came up with the idea in my novel of exploring, well, what if they had come up with those ideas? And what if those ideas had been suppressed by an evil conspiracy? And I was a little concerned that I might have challenged my readers' suspension of disbelief that there could be a conspiracy trying to take over the world and suppress science and so forth. So I set it in an alternate timeline. I made it an alternate history novel. But in my alternate history novel, the ideas I came up with were actually discovered in the 19th century. And the hero of my novels is a high school student who discovers an old book in an overlooked technical library in his Appalachian hometown, and discovers that the scans of that book online don't correspond to the text that is in the books he's reading. And that clue leads him on a mission to try to figure out what's going on and what is the hidden truth about why these discoveries were suppressed. So that's the premise of my Hidden Truth novels. In the second novel, A Rambling Wreck, the hero and his friend start off their freshman year at Georgia Tech, trying to get the education they're going to need to unlock the hidden truth and figure out who's behind it and what's going on. And in the process, there is they thwart an attempted social justice takeover of the university. So it was a very timely topic. And finally, the third novel of the series, they have a summer internship to go to where they've infiltrated the secret cabal and are going to the cabal's summer meeting on Jekyll Island to try to disrupt the proceedings and investigate further. So that's the premise of my Hidden Truth novels.
Are you still working on that series, or is it just the 3 books?
So far it's 3 books. There is going to be a 4th and concluding book. I'm about a third of the way or a quarter of the way into it, and I have it outlined, but I had to put that on the back burner to finish Fields of Energy. So that's Fields and Energy. That's the next project I'm going to tackle once I get through with the Fields and Energy books.
When do you think Fields and Energy will be out?
Well, it keeps getting bigger and bigger. It was originally going to be 1 book, but it became pretty clear I was going to blow past I think it was 750 page limit to do a hardcover if you self-publish on Amazon. So I decided it made sense to split it up into 2 volumes. So the good news is that the first volume will be out sooner, probably first half of this year. I'm on the final chapter of it right now, but then I have a whole nother book to do that'll probably take another year or 2 to crank out before I'll be able to return to the Hidden Truth series and complete it.
Gotcha. Yeah. So we might not get fiction from you again for another 2 years. Is that what you're saying?
Yeah, I'm afraid so.
That's how it goes sometimes, right?
Life intervenes. So, but I think people will enjoy the Fields and Energy book. I'm writing it so as to be accessible by lay people with an interest in science and technology. A large part of it is about the philosophy and the history of science and how these different fundamental notions like waves and particles have influenced our understanding of science. And it's been fascinating to me to dig into it, to see how our understanding of reality has oscillated back and forth between thinking of reality as being a plenum or a continuum versus thinking of it as atoms and void, as a vacuum with particles operating in it. And those 2 views, we've swung back and forth between those views several times since Aristotle and Democritus came up with them in the times of the ancient Greeks. And the prevailing wisdom right now is that reality is a synthesis of both properties in one entity, that particles are simultaneously waves. And the concept that I'm trying to push is that no, we have waves and particles, but they're 2 separate things. And that's the fundamental message of Fields and Energy.
And that's being serialized on your Substack. So you're basically giving access to this stuff for readers, even without waiting for the book.
You can follow my progress in writing it. I try to do a section a week. I've been slack over the holidays, and I'm taking a couple of weeks off. And the section I'm on right now, where I'm talking about relativity, has been particularly difficult. I originally had 1 small section on relativity, and then I was going to move on into quantum mechanics, which is what I'm really interested in. But I made the mistake of opening the hood and looking underneath and trying to take a closer look at relativity. And what I found was so disturbing about how bad the science was and what it means for the scientific establishment and kind of the cult of scientism that rules our modern day understanding. I wanted to dig into it in further depth. So I've got about that 1 section has exploded into about 8 different sections of the book. I'm currently working on section 7 of 8 out of them, so I should be able to finish them up and move on into quantum mechanics in the next couple months or so.
It's running away from you. What is drawing you, or let's rephrase, what initially was drawing you to the quantum material over the relativity material?
Well, what I discovered in my professional career working with electromagnetism and coming up with this idea of how fields guide the flow of energy, what I discovered is a picture of reality that turns out to be very similar to a picture which was considered and dismissed in the early days of quantum mechanics. A physicist named Louis de Broglie came up with he noted that Einstein had argued through the photoelectric effect that light waves had particle-like behavior. And de Broglie said, well, could we possibly have the reverse? Could particles have wave-like behavior? And it was that insight that led to Schrodinger's equation and a lot of the quantum mechanics we take for granted. But de Broglie took that further, and he argued that the waves were pilot waves that guided the motion of particles. So if you come to a two-slit interference, the pilot wave goes through both slits, it sets up an interference pattern, and then the particle itself only goes through one of the two slits. For a variety of technical and principally philosophic prejudices, reasons, those ideas were largely dismissed. But what I discovered is that classical electromagnetic physics has almost exactly the same picture. And that's convinced me that a picture very much like de Broglie's pilot wave picture is the correct interpretation and model for how quantum mechanics works. And so that's my interest in quantum mechanics, exploring that analogy and showing how you get to a pilot wave-like picture of quantum mechanics from a strictly classical electrodynamic perspective.
Let's jump back into your publications in general. You've got a handful of paperbacks, novels, and you've got a number of your works, I assume shorts, in anthologies. And, I feel like that's a great way to connect with the community. But you've kind of pushed things forward over the last year, I think, correct me if I'm wrong, with the based book sale. And that's fairly new.
Yeah, the based book sale has been around for a while. It's been evolving.
Okay.
Initially, there were some community efforts where there'd be a monthly sale, and if you wanted to include your book, everyone would put their book on sale for the same week and do a cross promotion. I thought that was just a marvelous way to promote books. One of the challenges is, as authors, we have our fan community. You can't just go to your fan community and say buy, 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 buy all the time and expect to make any progress. They'll get tired of hearing from you if you are shamelessly shilling and self-promoting yourself. But what the based book concept does is, by working together, you are effectively promoting other authors' books to your readers, and those authors are promoting your books to their readers. So it really is a win-win. The readers are getting exposed to a wide range of other authors they might not have heard of. Because all the books are being put on sale, the risk is very low. You're talking about books that are either free or 99 cents. So, you can just go through the based book sale listing and see what blurbs and what covers catch your eye, and put your, pay your 99 cents and take a chance on getting introduced to a new author. So it's really worked out very well, and I'm pleased at how it's grown from me just doing having a dozen or so authors selling maybe 20 books in the sale. The most recent one I had, I think, nearly 100 authors and almost 200 books total in the sale. So it's gotten very big, and the Substack community has been very helpful. It's really helped me automate the mailing list. I was having a lot of problems connecting with authors before because the emails I would send to my mailing list would get canceled by various email engines as spam. So I couldn't even talk to my authors reliably. But with Substack, I have a reliable mailing list for my authors and my readers, and you can do the coordination and get everyone lined up to participate in the based book sales.
Yeah, very cool. And the next one is happening in mid-February, you said.
The next one will be mid-February around President's Day. So it'll encompass actually Valentine's Day and President's Day weekend.
And when do people need to get their submissions into you?
Well, you'll want to come to basedbooksale.substack.com and sign up for the mailing list. I will be sending out a call for authors usually about 2 to 4 weeks before the sale. And authors just need to look for that and then put a comment in the post to let me know that you want your book included in the sale.
Yeah, very, very cool. You do a great job with that, and much appreciate, including my 2 fiction releases that I did over the course of last year in the December sale. I'm working on another release this month that is nonfiction. Is that allowed as well, or are you strictly fiction?
Well, it's mostly science fiction and fantasy, but there are a lot of different genres, including nonfiction in it. The nonfiction section's kind of small. I think I may have had as many as a dozen nonfiction books in the last sale, but I'd be delighted to include any book by an author who wants to identify as a based author.
So let's round things out here. Are there any points we have not addressed that you feel must be addressed? Any parting words or final thoughts if there are no missing pieces to this conversation?
Well, I think one of the key lessons I've learned that I welcome the opportunity to discuss with people is just how powerful and active the indie author movement is. There's been a comprehensive effort at place to homogenize our culture and to put the culture in the hands of very narrow straitjacket ideology, pushing social justice type themes and tropes. And I have been thrilled to see how many excellent authors are out there creating works that defy those stereotypes, that uphold standards of good storytelling and heroic storytelling, that aren't reliant on social justice, diversity checklists of characters. And people who have an interest in good storytelling should check out the books that are in the based book sale in particular, and just indie authors and Iron Age creators and superversive creators. There are a number of kind of parallel aligned movements there. There's just a lot of great art and books and comics out there if you decouple yourself from the mainstream gatekeepers and go looking for the independents who are doing such wonderful work.
Totally agree. Hans, thank you for joining me today. I appreciate you taking the time. Fantastic conversation. Excellent learning opportunity. Glad to hear about your incredibly in-depth knowledge and career and the work that you've done and what you're doing with not only your own writing, but the indie writing community.
Well, it's been a pleasure, and thank you so much for having me on and giving me this opportunity to talk with your listeners.